Good morning. Today we are going to have a class on clean area classification. What are clean areas? How to classify them? On what basis? On ISO as well as on federal basis we are classifying clean areas. So we'll look at what exactly is clean area. Myself Prashant Naik, Assistant Professor, Department of Pharmaceutics in JSM Institute of Pharmaceutical Science, Bangalore. So the learning objective is we are going to learn what exactly is a clean area, how to classify them, what are the size of the particles, what are the room area specifications. This all we will learn in clean area classification. So clean area classification, the clean or a buffer room is the secondary engineering control. It houses the primary engineering control like laminar airflow, BSC, CA, where aseptic compounding is actually performed. Now, clean room is a specially constructed enclosed area which contains one or more clean zones where the concentration of airborne particle is controlled using HEPA filters, continuous air circulation, and a physical barrier to non-filtered or outside air. Clean rooms establish appropriate environmental levels for airborne particulates, temperature, humidity, air pressure, airflow patterns. So, clean rooms are categorized by their constant air quality or the classes of air. Now, what is the classification of clean rooms and their properties? We will see. We have classified the clean rooms according to ISO and we have given them a class name class 10,000 or ISO class 7. So the property of this is they should have 10,000 or less particles of 0.5 microns in size, or maybe it can exist in a larger size for a given cubic feet of air. So when we calculate a given cubic feet of air, the size of the particle should always be 0.5 and it should be 10,000 or less particles. So we can grade them or we can tell them as ISO class 7 room. The next one is class 1000. We call it as ISO class 6, which has 1000 or less particles of 0.5 microns and larger size exist in the given cubic feet of air. So ISO class 6 contains 1000 or less particles. Size will be always around 0.5 microns. Class 100. This is designed by ISO class 5 in which we should have 100 or less particles of 0.5 microns and larger size can be existing in a given cubic feet of air. So the whole calculation of the rooms are designed based on the given cubic feet of air that we calculate. In that given cubic feet of air, if it is 100 or less particles, the size of the particles can be from 0.5 or more. It is classified as ISO class 7 or class 100. So lower the classification number, cleaner is the area or clean is the free area, air. A clean room includes UV irradiation. UV lamps are fitted in the clean room so that whatever organisms will be present, there will be no contamination present in that area. Airlock entry ports are kept for maintaining proper airlock. Specially filtration of treatment systems for incoming air. HEPA filters are kept so that the incoming air is pure, free from dust particles and organisms. Sticky mats for removing particulate matter from shoes and positive room pressure for controlling entry of contamination from adjacent room. Clean rooms are divided into different classes in standards. The table 2 will list out the equivalence of the classes from different international standards. For manufacturing sterile products, a certain classification of table 3 is given. With grades A to D, we will learn this table 3 and characterized to the activity category table 3 and 4 are being used. Now let us look at the table 2. Table 2 class limits are given according to the federal standard 209D and ISO standards. What exactly is this federal standard and ISO standard? We will see. On the table you can see table 2 class federal will be 1, ISO standard will be 3. So in this what we have seen is the measured particle size in micrometers If it is zero point 0.1 micron, there should be only 1000 particles. If it is 0.2 micron, it should be 237 particles. 0.3 micron, 102. 0.5 micron should be 1 or less than that, and it should be 1 micron should be 8. So as we go on, the particle size should get reduced from 1000 from 0.1 microns to 8 to 10 in 1 micron size. So as we go to the 10 class 10 Federal 29D 209D class 10 and ISO standard 4 consists of 10,000 particles, and the major particle size of 0.2 microns will be 2370. So 10 times it increases from the class 1, and ISO 3, when it comes to ISO 4, it increases 10 times. So the particle size should be around 102 for 0.1. It can be over 1020. Micrometer of 0.5 should be around 10, and micrometers of 1 should be around 80. So this is the classification 80 to 83. So this is how in the case of 5 micron there should be no particles, or particle size should not be present. As we go to 1000 to 10,000, in 10,000 we cannot find any particles of 0.1 micron, 0.2 micron, 0.3 micron. So this starts from 0.5 microns, where we can see 10,000 particles. So this is called as ISO class 7, ISO class 7 and Federal 292 1000, in which we can see 1000 particles of 0.5, 1 we can see 1000 particles, and in 5 you can see thousands of particles. So 10,000, 80,000 and around 3,000. As we go to class 7 ISO to 8, the same thing it is, with just an increment of 10 times from the previous one. So in 5 microns there will be maximum particles seen in the area, where we have made a standard of ISO 8 and Federal 29D we have told as 1 lakh. Hope you understood this table. The table increases 10 times as you go from Federal standard 1 to 10, 10 to 100, 100 to 1000, 1000 to 10,000 and to 1 lakh. Same way, 1 represents ISO 3, 10 represents ISO 4 and 100 represents ISO 4 and so on. Now table 3 deals with air particle classification system for manufacturing of sterile products. So in this we have graded A, B, C, D classes of room. In this grade we have permitted number of particles which is at rest and which is in operation. We are going to see a range of 0.5 microns and 5 microns. When we say about 0.5 micron in class A should be 3500 particles and 5 micron should be 0. In the case of operation, it should be 3500 in 0.5 micron and 5 microns should be always 0. In the class B, grade B room, we can see a particle size of 3500 in 0.5 microns at rest, but at 5 micrometers size should not be present. In case of operation, in room B we can see 350,000 particles, whereas in the case of 5 microns you should always be 2000 particles. Class C and D, as you see in the chart, contains 350,000, class D contains 35 lakhs. In this 5 microns, the first one will be 2000 particles and the next one will be 20,000. So there is an increment of 10 times from class C to class D. Whereas in the case of operation condition, it can be 35 lakhs to 20,000, and in the case of D, it is not well defined, it can be more than that particle size. So class A and B are very good standards, which is having minimum number of particle size for manufacturing of sterile products. Now we will see table 4, which tells about terminally sterilized products in grade A, B, C, D. Examples of operation: filling of products will be done in grade A with mutually no risk or minimal risk, unusual at risk. C, A, B, C, we will see preparation of solutions where unusual at risk, filling of products can be done. In class D, we can see preparation of solutions and components for subsequent filling. Now coming to the remarks. In order to reach the air grades B, C and D, the number of air changes should be related to the room size and the equipment and person in the room. Operating people. The air system should be provided with HEPA filter grades for A, B and C. After 15 to 20 minutes of cleanup period, an unnamed state, no manual activity should be received. Appropriate alert and action limits should be fixed for particulate and microbial monitoring results. A corrective action in the operating procedure should be taken in case these limits are exceeded. The need of other parameters like temperature, relative humidity, etc. depends on the nature of the product and the manufacturing procedure. Most of the products should be prepared in grade D environment, where grade C environment should be used in case of unusual risk. Example of aseptic parameters in table 5. Grades are A, B, A, C, D. Example in grade A, aseptic filling, preparation and filling. C, we can see preparation of solution to be filtered. In D, handling of components after washing. The components after washing should be handled in grade D environment. Sterile material, starting material should be handled in grade A environment with grade B background. Solutions to be filtered should be prepared in grade C environment, where if not filtered, the preparation should be done in grade A environment with grade B background. Aseptically prepared products should be handled and filled in grade A environment with grade B background. The sterile ointments, cream, suspension, emulsion should be prepared and filled in grade A environment with grade B background when the product is exposed and is not subsequently filtered. Control of purity of zones by particulates in operating states and microbial control at any aseptic production area is required. Table 6 recommends limits for microbial contamination in the operating state average values. So air sampling in per cubic feet per centimeter cube, sterile plates with diameter of 90 millimeter CFU per 4 hours, contact plates with diameter of 55 millimeter, glow print 5 fingers CFU per glow. If you see in grade A, it should be air sampling should be 1 CFU per meter cube organism, colony forming units. It should be less than 1 in all sterile plate, contact plate and glow prints. In the case of B, we can see air sampling can be 10. So it increases 10 times every time. And the sterile plates will be 5, contact plates will be 5, glow plates will be 5. In case of grade C, air sampling surface can have 10,100 of organisms colonies, 50 in the case of settled plates, 25 in the plate contact plates. In the grade C, we can see 200 colonies forming units per meter cube in the case of air sampling, and in the case of sterile plate we can see 100 and 50 in the cases of contact plates and nothing in glow print. So this is the individual settled plates are exposed to 4 hours or less, and CFU stands for colony forming units. Warning, limitation and action for contamination by particles and microbes depend on controlling results. Also corrective action should be provided in case of exceeded the above limits. This been taken by N.K. Jain, Pharmaceutical Microbiology, and Manivir R. Singh Patel, Pharmaceutical Microbiology. So to summarize the things, we have learned the various grades. What are the grades A, B, C, D? What is the ISO standards what we have put for the sterile area? We have to maintain the sterile area A and B for sterile products. C and D can be done for filtering of the products. So but all prepared products should have or should be made in grade A and B, which has very less number of contamination and very less number of particle sizes. So that's all for today. Have a nice day. Thank you.